So welcome to everyone. Welcome to this meeting of the CCTF task group working towards a continuous UTC. I see we have 29 people online, and I think we can start. So let me share my screen. So thank you for joining us. So we can see also Noël Dimarque, the president of the CCTF. Thank you for being here. We see also we have as a guest Christian Bisoard from the IERS. He doesn't have a camera, but I hope he's hearing us and he will make a presentation. And then we have many new colleagues today, so it's difficult to welcome anyone one by one, but thanks for being here. You know that we have important task because the resolution 4 of the last General Conference in 2022 asked for the next General Conference in 2026 to define some details of a decision which has been taken. And the decision is that the maximum value for the difference UT1 minus UTC will be increased in or before 2035. So we have to decide exactly when this will be implemented. Then we have to propose a new maximum value for the difference UT1 minus UTC that will ensure the continuity of UTC for at least a century. So we have to decide what we want to do. We need to prepare a plan for the implementation, and we need also to propose a time period for the review by the General Conference of this new maximum value, because maybe in the future there will be new understanding, better model for the Earth rotation, and so a decision taken now to be applied very far in the future maybe will have important revision in the future. So starting from the resolution 4, we have formed a task group. This task group has to prepare a draft resolution for the next General Conference on the topic we have seen. We have also to work together the International Telecommunication Union, particularly because the World Radio Conference last November 2023 discussed this item and the need to broadcast UTC and UT1 minus UTC with the correct code. And we have to interact with the other communities that are impacted by the change in UTC to prepare all the communities and also to take into account the need of the different communities. This group has been formed with several colleagues that are from UTC laboratory, but also active in the International Telecommunication Union Working Party or related to the GNSS. We have the chair of the Regional Meteorology Organization that represent an entire region. We have the representative of the liaison, which are the International Astronomical Union, the International GNSS Service, International Union of Geodesy and Geophysics, Union of Radio Science, and the International Telecommunication Union. And today we have some new colleagues, so welcome. Sometimes new people, new laboratory, ask to be involved because they are interested in this discussion or because they can bring a contribution. And so we are happy to welcome all the colleagues today. Just let me say very briefly that the main work we have to do together with the International Telecommunication Union was quite demanding, but it was successful because when we met in Dubai in 2023, we were able to have a common understanding and a common agreement with the ITU. About that, we will have a talk today. So the agenda of today is the one that you see. First, Joseph Ashkar, who is the chair of the ITU R Working Party 7A, will tell us what happened at the World Radio Conference, which is the type of agreement that we have with the ITU, and what remains to be done by both parties. Then we will have Christian Bisward from the International Earth and Rotation Service, that who will tell us his study about the Earth rotation, and particularly about the possibility of a negative leap second. You know that the fact of having a possibility of a negative leap second is quite scaring, and this may help in understanding when we have to change UTC, maybe avoiding a negative leap second if we have the perception that this may arrive before 2035. Then Judah Levine will make a presentation on a possible solution to extend the tolerance UT1 minus UTC. And all these presentations are mostly given to open the discussion and to hear your point of view, because at the end we will discuss also which are the main messages that we want to bring to international congresses, to user fora, and to the CCTF at the end of this year concerning when and what about UT1 and UTC. So I will stop my screen sharing, and I invite Joseph to start with the first presentation. Thank you, Joseph, for being here. The three presentations are more or less 20 minutes, and then we hope to have the same time for discussion. So please, Joseph.
Thank you, Patricia. Bonjour à toutes et à tous. Do you hear me?
Yes.
Okay, so I will share my screen. Do you see my slides? Okay.
Good.
Okay, so hello everyone. I'm pleased to give you the information about the endorsement at WRT 23 of the decision by the BIPM to adopt continuous UTC at the time reference. Here is the outline of my presentation. I first briefly present an overview of the ITU, then I describe the WRC process and contributions submitted in relation to UTC. This will be followed by presenting the key outcomes obtained, and I will conclude with the work in progress to implement the WRT 23 Resolution 655. The International Telecommunication Union is the United Nations specialized agency for information and communication technologies, founded on 17 May 1865. On this slide, the overall structure of the ITU is shown. At the top, the Plenipotentiary Conference, which defines the ITU Constitution and Convention. At the bottom, the organization of the ITU headquarters, and in the middle, the holding of meetings, assemblies, and conferences. It is at this level that meetings take place of Working Party 7A within a study group. The results are then approved or debated at the assemblies or at the highest level, therefore at conferences. In addition to the General Secretariat, ITU had three main areas of activity organized in sectors which work through conferences and meetings. From the right, the ITUD delivers technical assistance in terms of ICT in developing countries. Next, the ITU-T develops international ICT standards needed to building infrastructure. And then the ITU-R covers radio frequency spectrum by all radio communication services, including those using satellite orbits. It is in this sector where standard frequency and time signals emissions are developed and, when necessary, rely on the ICT standards developed by the ITU-T. Here is an overview of the working parties structures within the study groups. Highlighted in blue, the responsible groups for studies on WRC 27 agenda items. This mainly concern satellite, terrestrial, and science services. On this slide are displayed the contributing groups to studies on WRC 27 agenda items. You will see here that the Working Party 7A is involved in few studies related to all the services concerned: satellite, terrestrial, and science services. After a brief overview of ITU, let's now move on to the WRC held in Dubai from 20 November to 15 December 2023, and the key outcomes on UTC. Let's start with some numbers. Around 4,000 participants, more than 160 administrations, and more than 150 observers represented, almost 1,000 documents, and more than 6,000 proposals were submitted. According to the WRC process, in addition to the director's report, CPM report, and radio assembly report, proposals from member states and coordinated common proposals from regional telecommunication groups formed the basis of the work during the conference. International organizations can also submit information documents related to agenda items through the ITU Secretary General. It is through the director's report that Working Party 7A contributes to a specific item on the WRT 23 agenda in accordance with the Resolution 655. This specific point is also reflected in the CPM report submitted to WRT 23. As a result of the studies carried out by the Working Party, coordinated common proposals on the Resolution 655 were submitted by 4 regional groups: APT, CEPT, CTEL, and RCC. 2 proposals were submitted by 2 ITU member states, China and the United Arab Emirates. The BIPM provides its support through an information document on the Resolution 655 submitted to the conference. After 3 weeks of intense work, delegates managed to agree on a common proposal leading to the revision of Resolution 655 on the definition of timescale and dissemination of time signals via radio communication systems. This revision of Resolution 655 is now included in the final acts of the conference and will be incorporated by reference in the radio regulations being updated in accordance with Article 13, Item 8.9 of the ITU Constitution, and which will be released in late 2024 or early 2025, which is an international treaty signed by the member states of the ITU. This slide shows an overview of the different contributions submitted to the conference regarding Resolution 655. The BR Director's report refers to results of studies carried out by the Working Party 7A, the regional groups APT, CEPT, CTEL, and RCC. It is worth mentioning here that RCC's contribution diverged significantly from other regions' contributions. Member states, China and UAE, and BIPM positions through the ITU Secretary General. At WRC 23, Resolution 655 was considered under Agenda Item 9.1. The plenary assigned the topic to Committee 6, which delegated it to Working Group 6A, which in turn delegated it to Subworking Group 6A3. Subworking Group 6A3 established a drafting group to consider contributions on the topic submitted to the conference. The introduction of inputs documents took place during the first subworking group meeting headed by Germany. This was followed in a second step by consideration of related compilation documents. A drafting group headed by France held 6 meetings and prepared a draft document, including divergent views, and submitted it as an informal temp document for further consideration by the subworking group. The subworking group considered that more work remains necessary and decided to create an offline group informally coordinated by France. The drafting group chair reported to the meeting on the work accomplished and outstanding issues. A new version of the document still containing divergent points of views was prepared by the subworking group at its last meeting and then submitted to Working Group 6A, though higher level, for further consideration. The subworking group chair reported to the meeting on the work accomplished by the subworking group and outstanding issues. Working Group 6A, chaired by the US, agrees to continue offline work. This slide highlights some key events occurring during the conference, once discussions were elevated to the level of Working Group 6A. The offline group worked hard day and night over the period from 1 to 7 December 2023. Contributions from representatives of the regions, delegates from member states, and delegates from sector members took part in the offline discussions. In addition to the discussions, the 2 regions which did not express a position on the issue at the start of the conference evolved their view or position during the conference. The Arab States region appointed UAE coordinator on Resolution 655, thereby adopting the position of the UAE. The African region did not appoint a coordinator on this item, but communicated through its coordinator on radio communications by a message sent to the CEPT coordinator on Resolution 655 with copy to ECHO, I quote, hoping the matter closed in your favor as CEPT. The offline work having been completed after 7 intense days, the subworking group chair reported the interim conclusions to the Working Group 6A meeting. On a request from CEPT coordinator on behalf of the offline group, and with the agreement of Working Group 6A chair, Committee 6 chair, and ITU staff, the draft final conclusions were considered at the meeting. After some minor changes, conclusions were approved by Working Group 6A. Applause rang out in the meeting room. The chair of Working Group 6A announced the sending of the document approved during the meeting for further consideration by Committee 6. The Working Group 6A chair reported to the Committee 6 meeting led by Cameroon on the work accomplished and the consensus reached. After some minor changes, conclusions were approved by Committee 6. Applause rang out in the meeting room again for the second time. The chair of Committee 6 announced the sending of the document approved at this meeting to Editorial Committee 7, led by France, for language verification and translation into the 6 official ITU languages, prior to its submission to the conference plenary. The chair of Committee 7 presented the revised document to the 8th conference plenary meeting, where it was approved at first reading, then in a row at a second reading. Consequently, the revised Resolution 655 is now published in the final act of the conference. Here is an overview of the atmosphere that dominated these 3 weeks of work during the conference in Dubai. Appearing on the screen, the key outcomes of WRT 23 on UTC issue. First, endorsement of the decision by the BIPM to adopt continuous UTC at the time reference. Second, ITUR to cooperate further with the BIPM to define a new maximum value for UT1 minus UTC and on the implementation date in a draft resolution to be adopted by the CGPM in 2026. Third, this has been clearly reflected through the revision of Resolution 655, paving the way to update recommendation TF 460-6 on standard frequency and time signal emission. It is the result of a consensus reached between all regional telecommunication organizations after long and difficult discussions with the strong support and strong involvement of BIPM. It was a great success. I will now go quickly through the different sections of the resolution. I'm not going to dwell too much on the content since you know it very well, but I will focus on what has evolved. Section considering updated according to the MOU between BIPM and ITU. Section considering further updated according to the Memorandum of Understanding BIPM-ITU. Section noting unchanged. Section realizing is a new section added concerning the task group created by the BIPM. Section recognizing A to D unchanged. Section recognizing E to H are new items added. So recognizing at higher level of ITU, so WRC, the Memorandum of Understanding between BIPM and ITU, recognizing Resolution 2 of the CGPM in 2018, recognizing Resolution 4 of the CGPM in 2022, and approving report TF 2511. Section recognizing I2K are new items added, indicating that the difference between UT1 and UTC must be greater than 100 seconds. Section resolves to invite the ITUR was updated, and section resolves have been completely revised with a new text, indicating 2035 as a possible date for the implementation of continuous UTC. And finally, sections instructs and invites were updated. What are the next steps after the conference? The group is working on the implementation of Resolution 655 related to continuous UTC and its dissemination. The main tasks to be carried out are displayed on the screen. The WRC instructs the Secretary General to bring this resolution to the attention of relevant international organizations. Working Party 7A to cooperate further with the BIPM through the task group of the CCTF. Following the WRC 23 resolves, Working Party 7A will carry out new studies which will lead to the development of a new report and the revision of the related recommendations in accordance with the decisions taken. And the WRC instructs the director of BR to report on the progress of this resolution to WRC 27, sorry. Here is a conceivable scenario through the WRC cycle for implementing Resolution 655 revised at WRC 23 with a view to WRC 27. So we are here, Working Party 7A, to prepare a draft new report and a draft revised recommendation TF 460, but not limited to. Working Party 7A to prepare a note to the BR Director on the progress of implementation of Resolution 655. To seek adoption approval by Study Group 7 and by the Radio Assembly 27, contributions can also be expected from ITU member states to WRC 27 and decision to be taken by WRC 27. So the next meeting of Working Party 7A is confirmed from 16 to 20 September 2024 at Almaty. ITU membership are requested to submit contributions. NMIs and DIs are invited to take part in the studies carried out by the Working Party 7A. Thank you for your attention.
Thank you, Joseph, for your presentation and for go again over all the process we had at the World Radio Conference, which makes me remind a lot of things. And I understand that this presentation contained many details, so maybe not each of us is familiar with this detail, but we have time for question, and particularly to clarify, if it is not yet clear, which is now the role of this task group, what ITU is expecting from us. So please ask your question. I would like to start saying that the meeting, the World Radio Conference in last November was very complex because it was difficult to have a common view with all the delegation of the ITU, which are usually delegation coming from telecommunication, so people expert in telecommunication. There were not so many people from our UTC community. And so it was very important that each national ITU delegation was in contact with their national UTC laboratory, because they were very happy to have the view of their national colleagues. They listened to me and to the other delegates, but clearly each national delegation is very much interested in knowing which are the interests and the point of view of their national colleagues. So I would like to take the opportunity to thank most of you a lot. So I don't know today how many people we have here, and I don't see your face. I see just the names, but for sure I know that each of you was very active in that period, because we needed to have a contact between the BIPM, the National UTC Laboratory, contacting their ITU delegation in Dubai. So there was a very, very important and also intense exchange. And so I would like to thank you very much for that, because we would not have reached anything if you were not behind the national delegation and you were not helping in converging towards a common understanding. So thank you very much. Thank you to all the countries and also to the regional organization that helped. And also we had Noel Dimarc working in the International Committee of Weight and Measurements. So all together we were able to reach an important consensus. I see in the chat someone is asking if the presentation will be shared. Yes, all the presentation will be on the CCTF webpage, so we will have time to go through the presentation again. And also we are recording this meeting, so maybe if you want, we can also share the recording if you want to see it again. So Joseph, may we summarize that after all the discussion that we had, now there is an agreement between the BIPM, in general the metrology community, and the telecommunication community, that UTC will become a continuous time scale. We collaborate to fix together the implementation date and the new tolerance. The ITU expressed the preference that the new tolerance is at least 100 seconds and that the implementation date is 2035. This is a preference, and the decision will be taken by the General Conference in 2026. Is it correct?
Yes, it's correct. This is clearly indicated in the Resolution 655 in the realizing.
And what remains to be done, which is quite important at the level of the ITU Working Party 7A, is to update the recommendation for 60, which describes the code for broadcasting the offset UT1 minus UTC. As maybe some of you may know, there are special radio signals which are disseminating UTC and also the offset UT1 minus UTC. This offset at the moment is limited to 1 second. When it will increase, the code for the transmission needs to be updated. And so it is now important, and I would also say urgent task of ITU Working Party 7A to update this code to correctly transmit UT1 minus UTC when this will be larger than 1 second.
Yes, so Working Party 7A started to discuss the revision of recommendation TF460. We just started. Also IEEE and IETF are invited to contribute to the studies because WRT Resolution 655 calls also to include wired technology for disseminating standard frequency and time signals also in the studies. Contributions are expected from administrations and from international organizations as well.
And maybe, Joseph, we can take the opportunity to invite all the colleagues here who represents a UTC laboratory, or in any case, the UTC community, to work closely with their ITU national delegation. Many of us are already doing that, but maybe other colleagues could join, because we see that when we discuss time and frequency metrology in the ITU meetings, it is very important to have expertise coming from our community.
Sure. So NMIs and DIs are welcome, are invited to take part in the studies carried out by the Working Party 7A. Because it's very important. This concerns standard frequency and time signals emissions, and we need all to receive a signal. So this is very important. So please join the studies. There is some rules to follow, and so you are invited to contact your national point of contact at ITU. Then your national contact will provide you with the procedure to join the meetings of ITUR.
Thank you, Joseph. Any other comments? Or let's hope everything is completely clear. Yes, so thank you, Joseph. And we can progress with the second topic of the meeting, which is studies on a possible negative leap second. And the presentation will be given by Christian Bizoard from the International Earth Rotation and Service Center. Christian.
So, dear colleagues, chers collègues, hello. I will try to share my screen first. Do you see it? May I start?
It is not in presentation mode.
It's not in presentation mode. And like this, is it okay?
Yeah. Yes.
So do you see the title?
We see the title. Yeah, thank you.
So some time ago, many of my colleagues urged me to check a paper of an American geophysicist Duncan Agnew about the possibility of negative leap second by the end of the decade. But before to dig deeper, I would like to recall some basic notions pertaining to Earth rotation. So from this slide, you have to sorry, I get cold. You have to. I would like to point out that astrogeodesy allows to determine the length of the offset with respect the atomic day or of 86,400 seconds of the International System of Units. Astrogeodesy also allows to determine the so-called Earth rotation time, or UT1, which is defined through the angle of rotation measured or determined thanks to the observation provided by the very long baseline interferometry. And from the Earth rotation angle through a linear law, scaling law, you can define at any instance the Earth rotation time and determine the difference of this Earth rotation time with respect to more stable time, the atomic time, here noticed by the letter small t. And by derivation, time derivation of the Earth rotation time, you get also the relative the relative difference of the length of day, delta load over, you see, delta load over load 0, which is the notation for the total length of day, the reference length of day, or that is the atomic length of day of 86,400 seconds. So leap second, you know, I skip that slides. Here I show you difference of UT1 with respect to universal time coordinated since the leap second system exists since the 70s, and you noticed the unusual behavior of that time difference since the beginning of the 2020s, because of the fact that since the 2020, the length of day became smaller than the atomic day. So as it becomes smaller, somehow the Earth rotation time beats, I would say, the second quicker than the atomic, than the international, the temps atomique international, atomic time. So, and you can see from that plot that by 2030, the UT1 could exceed, if we extrapolate the trend, the UT1 minus UTC could exceed UTC by more than 500 milliseconds. So we would have then to remove to add a second in UT1 to remove a second in UT1 in order to keep the synchronization with UT1 to 1 second, to 0.9 second, more exactly. And I use predict such negative leap second by 2030s. You have to remove. So I will, in that presentation, I will present you two kinds of prediction. One prediction is based upon the historical record of UT1, extrapolation of a very simple model based as I will show you now. And the second part of my presentation will focus on the prediction based upon a physical analysis of the causes which the causes of the length of day variation of the especially of the decadal, multi-decadal length of day variation. So let us begin with simple fact that on the long run, the length of day increases linearly, mainly because of the so-called tidal friction, of the fact that Earth rotation lost energy with centuries. So this corresponds to an increase of the length of day of about 0.7 milliseconds per century. And when you integrate that relation in order to find the effect on the Earth rotation, because I remind you that the time derivative of the Earth rotation is to within a factor the length of day offset. So by integrating that linear trend in the length of day, you obtain for the Earth rotation time variation a parabolic expression of which I give you the coefficients here. And of which I give you the plot since beginning of the 19th century. The model, the parabolic model is the blue curve. The red model gives you the observation of UT1 minus TI, more exactly because TI appears at the end of the fetus. So before TI, it was ephemeris time. Ephemeris time, which, as you know, present a constant offset with respect TI of that is 32 seconds, 32.144 seconds. So you can see that this parabolic model fits much the observation of UT1 to within some seconds. So in order to, this clearly shows that you cannot predict, you cannot synchronize that the parabolic model is not enough to model the difference between UT1 and TI with a precision less than 1 second. So you have for that to consider the so-called decadal or multi-decadal variation in UT1 that have been detected in the 30s of the late century of the 20th century. When removing, when removing those that parabolic term from the observation, the decadal, multi-decadal variation appear. And recently, I discovered somehow that, in contrast to what I used to believe until now, there were long-term regularities. It's a long-term irregularity in about 136 years. Therefore, I decided to model, but it will become after the transparency. So I decided to model the UT1 multi-decadal variation through a periodic term and with its harmonic, and that is a model of 8 harmonics. And that allow to match quite well the observation of UT1, which is represented here by the dashed blue curve. And we can predict the UT1 for the next decade by a simple extrapolation of that harmonic model, so superimposed to the parabolic term, and that gives you the dashed red curve. You see also the extrapolation of the parabolic term of the model. But the parabolic term of the model has not, as I tell you, has not the required precision to monitor UT1 with a precision less than 1 second. So in the bottom plot, you see the same than the upper plot, but over for the last year and prediction until 2030. So according to that plot, you can see that a common leap second, not a negative, but we will have to do a common leap second, to apply the common leap second by 2029, according to that extrapolation of the somehow of the historical record of UT1. This is the same. This is the corresponding plot for the length of the variation. So according to this plot, you can see that the decreasing phase of the length of day, which has begun in the 70s, seems to have stopped. So we will have now an increase of the length of day over the next decade, according to that prediction. So now I come to the second part of my presentation. We will consider the physical cause of the length of day or from modeling for predicting UT1. And what you see from length of the plot from the 70s at least, this is a decrease of the length of day, so an acceleration of the Earth rotation speed with a rate of about minus 5 milliseconds per century. This acceleration of the rotation speeds can be seen as a transfer of angular momentum between the liquid core and the mantle. So the liquid core lost is its angular momentum. So it means it decelerates for the benefit of the mantle, which accelerates. And this corresponds, according to modeling of the angular momentum motion, especially in the Grenoble University at ESTER, from modeling of the motion in the core, we can conclude that since the 70s, the fluid core rotation has caused an acceleration of the mantle or a decrease of the length of day with a rate of minus 7.6 milliseconds per century. But this is not the at that time scale, that over decades, over some decades, this is not the only phenomenon at stake. You have also to consider the secular effect produced by the glacial isostatic adjustment and the tidal friction. So tidal friction has an effect of about positive effect on the length of day of about 1.7 milliseconds per century, so compensating the core effect. And the glacial isostatic adjustment also accelerates the glacial isostatic adjustment also accelerates the Earth rotation at a rate here. Sorry, it's not indicated, but it's about minus 1 millisecond per century. So anyway, when you combine all those secular effects, when you model all those secular effects, you obtain something which is close to the observed weight, that is minus 5.8 milliseconds per century. Here, this is a slide in order to show you that overall cause, especially linked with the mass distribution in the so-called hydro-atmospheric layer of the Earth, so has no effect on such time scales, so can be neglected in the budget of the length of day trend. So now I come to the problem which has been raised by in the paper of Agnew, is that the fact that since the 2000s, the effect associated with the glacial isostatic adjustment has been has disappeared because it is now hidden by the present mass transfer from continental ice caps to ocean, and this has caused in the geopotential, in the coefficient G2, degree 2 coefficient of the geopotential, an inversion of the trends. So now the trend of the G2 coefficient is increasing, and from that inversion, from that geopotential coefficient, we can compute an effect, a secular effect of corresponding linear rate on the length of day. Oh, sorry, here I show you on that slide. You see I wrote the effect which is caused by the glacial isostatic adjustment on the length of day, which is about -1 millisecond per century. But now that effect is, I told you, is compensated by the melting of the continental ice caps, by the mass transfer from Arctic or Antarctic ice caps to the worldwide oceans. And that produced a positive effect on the length of day, which is given here at the rate of about 0.7 milliseconds per century. No, sorry. 1.9 milliseconds per century. So accounting for all those model trends, that is the trend caused by the core, the trend, the secular trend compensated now by the transfer of mass from ice continental caps to the oceans. We have the strength in the length of day is still negative, but a little bit less than it was before 2000. So anyway, it's negative, and if it is negative, this will have for consequence to produce an increase of UT1, and according to the plot which is given here on the right, this will have for consequence to produce a negative millisecond in 20. So you see, 2032. We will have in that year to consider the possibility of removing a second in UTC. But there is no evidence that the trend, the negative trend caused by the fluid core will continue, because when you see I will show you on that plot, when you choose the historical record of the length of day, you can see that acceleration phase of the length of day has the one that began in the 70s, that such acceleration phases do not last more than 50 years. So we have already with the present phase has begun in the 70s. So it's at least 54 years. So according to the past behavior of the length of day, we can predict that soon such a phase, such acceleration phase will regress, and we will have now in the coming year, we will have again an increase, sorry, of the length of day. So a positive trend in the length of day. So the paper of Agnew is somehow, we'll see, the prediction done by Agnew is quite risky because you don't have any evidence that this negative trend in the length of day because of the core will continue. So I consider alternative scenario. So we can consider that first that the free core effect will be compensated totally by the phenomenon, by the tidal friction combined with the glass isostatic adjustment and present mass transfer from ice caps to the oceans. So then we will have the red curve on the right plot of UT1. But we can also consider that the fluid core angular momentum is now stabilized. And then we will have a positive trend for the length of day, a positive trend corresponding in the right plot to the orange prediction for UT1 that leads then to a common ellipsogon in 2032s. Do we have still time to do it? Hello?
Yes, sir. If
I
you
have still time. I have still time.
If you have a couple of minutes,
I have
if they are sufficient.
It's sufficient. Yes, it's sufficient. Here, I present you some details of the paper of news, of which principal thesis is to affirm that the present ice melting has a quadratic form somehow on the produce a quadratic compensation in the length of day. But according to my own estimation, I do not observe. I think that that quadratic estimation is overestimated. So, and according to my own estimate, I obtain a smaller effect for that for the ice melting. So I compare the estimates of Agnews at the bottom part of the slide, which is about 2.7 milliseconds per century, to my own estimates based upon the time series of the geopotential of degree 2. So I obtain a smaller value, which actually does not compensate at all if the present effect, present and trend observed into the core. But as I told you, I think that now the core effect is stabilized because when you see a model based upon model of Grenoble University based upon geodynamo theory and observation of the magnetic field, you can see that according to those model, the angular momentum caused by the fluid core associated with the fluid core, is stabilized since 10 years already. So there is no more acceleration, no more decrease of the length of day associated with the fluid core according to that models. So this is also some fragments of the paper of Agnews in which we can see Neronus plots. There is a confusion between TI and TT in the paper. And you said in the left plot give you the prediction of Agnews according an extrapolation, as you see, of the length of the decrease after the removing of the effect of the glacial isostatic adjustment, GER, after the removing of the present mass transfer from ice caps to oceans, and after the removing of the tidal friction. So after removing those trends, he obtains the dashed line, which he extrapolates. But as I tell you, this is this extrapolation considers that the core effect is still continuing. So the core trend is, but there is this is not evident at all. So in order to summarize the small studies, I will see that we have here two non-conclusive ways for predicting leaf seconds. First kind of prediction is based upon a simple model composed of a parabolic and of a periodic terms, based upon a time series of about 200 years of UT1 determinations. And this lead then to predict a common leap second by the end of the decade. If we look in at the causes, physical causes of the length of day, consider that the core mantle interaction, the present day mass transfer from ice caps to oceans, the glacial isostatic adjustment and tidal friction. So we have presently still a negative slope in average. So average since the 70s, negative slopes. But there is no evidence that these negative slopes will continue. So two options can be considered. First, that's the core, as Agnews considered, that the core will continue its deceleration. So the length of day will still decrease with the rate of minus 5 milliseconds per century. And then the UTC is to be advanced of 1 second by 2032. So we will have a negative leaf second. This is also prediction of Agnew. So the second option is that the core the core deceleration has stopped. And there are many physical evidence for that, and especially a model developed at Grenoble University. So then we will have to apply a common leap second by 2033 if that system of leap second is maintained. So all bets are off. So I try to summarize that study by that graphics, that plot for UT1, UT6 extrapolated according to the two scenario I've considered. So fluid core deceleration continues, and then we will have to apply a negative leaf second by 2030. And in the case where fluid second effect has reversed, and there will be no negative leap second. So thank you. I hope that for your attention, I hope you have understood something from my presentation.
Thank you, Christian. You gave us a lot of material, so we will have to study a lot. And thanks for trying to put together everything.
Yeah, may I add something, because you tell that we will have to define the tolerance between UT1 and UTC. So and for defining the tolerance, so that will be, so we have to look at the prediction over until the end of the century, for instance, on the long term, and I provide such a prediction. Where you see here on the bottom, the upper plot, I provide the prediction of UT1 and STAE, and you can see that according to that extrapolation, the difference between UT1 and TAE will be larger than 100 seconds. So if you want, so that can give you some guideline for that tolerance.
Yeah, so according to this model, the difference between UT1 and TAI will reach
the value larger than 100 seconds. So even by the 2100.
Yeah, so in less than 100 years.
In less than 100 years, yeah.
Okay, so thank you, Christian. Thank you a lot. Do we have any question or comments? I think that we have a lot of things to study, but there are interesting information either on the tolerance and on the probability of a negative leap second, which is scaring many people.
I think they will know. Now, I will I announced that leap second during the I was directing board 5 years ago, looking at the trend of the length of day, because then the length of the trend was very scary. But now the length of the string has stabilized, and again the length of day. I don't show you your observation, but again the length of day increases, and is above the atomic day. So I think that they will no negative leap seconds. You can sleep quietly.
Yeah, so I see many hands. Noel Dimarc, this is the first one.
Thank you, Christian, for this very detailed presentation. Not so sure to have understood everything. I have a naive question because you presented different models with different predictions. So at the beginning, I had the feeling that your model and Anu's model predict both a negative leap second, but not at the same time.
No,
so I'm wrong.
So you are wrong, because the first model, which is based upon an extrapolation, predict a common leap second. This is what the slide which is here.
Okay, and so we have two models with let's say not in discrepancies, but with different predictions. And as you know, we have to decide, we have to propose in 2026 a date of application of the new rule for continuous UTC. And so we have to analyze the risk. We have to choose the best date to minimize the risk to have a negative leap second before the date of application. And so how long time do you need is necessary to be able to discriminate between the different scenarios?
We have different scenarios. I think in 2 years, we will have more clear. Because we'll know in 2 years, I think we'll know if the length of day increase or not, will increase or not.
Okay, but we have to wait 2 years.
We have to wait for 1 or 2 years in order to know if the trend in the length of day has reversed or not.
Okay, so you think that even in 1 year we will have preliminary?
We have only preliminary results.
Okay.
And actually, in the paper of iNews is cannot be trusted anyway, because he get rid of the history. No, he consider what happens in the 70s. Here, you see the 70s. So this is in 70, indeed, we observe a negative trend on the length of day. But when you look back to the 1930s, since the beginning of the record of UT1, the measurement of UT1, you can see there have been a lot of reverse. And that deceleration, decreasing phase for the length of day does not last more than 60 years or 50 years, actually, 50 years. So there is no reason for extrapolating as Anu does over the next decade to extrapolate the negative trends of the length of day. There is no evidence for that, for doing that.
Thanks.
Thank you. We have another question by Giulio Tagliaferro.
I thank you very much for the presentation. I'm Giulio Tagliaferro from BIPM. If I understood your presentation correctly, it seems that these core mantle interaction are really key into.
This is a key phenomena. The core mantle is a key phenomena, and unfortunately, we cannot predict it.
That was my question. How well
we cannot predict. We can model it more or less well, but we cannot predict it. In order to model it, we need the observation of the magnetic field.
Okay.
The magnetic field, which is a kind of which reflects more or less the core motion. And from the core motion, you can infer the core angular momentum, and by conservation of the whole momentum of the core mantle system, you can calculate the length of the variation.
Okay, thank you very much. And
the magnetic field ever cannot be predicted. We cannot predict the magnetic field, the variation of the magnetic field. Can only observe till now.
Okay, thank you very much. I also have another very quick question. This periodicity you found in the historical data, do they have any connection with some geophysical phenomena, or it is a pure statistical?
I don't know, but if there is a connection, this will be a connection with the core, with the motion in the core, with geodynamo processes according to our present the conception of the motion in the core.
Thank you very much.
Then Dennis McCarthy.
Your microphone, Dennis.
There we are. My caution would be that causation is not correlation, and we have a lot of correlation, but we don't have necessary causation. I looked at two things. One, the geophysical modeling of the tidal friction, so-called tidal friction, which is fairly well documented and is, if you look at the geophysical models, it's fairly close to what was observed since the time of the Chinese eclipses.
Yes. Mm-hmm.
So we know that that's pretty much there. The other thing that we have numerical values of is the rise in ocean level, and they caused presumably by the melting of the ice caps and the glacial isostatic adjustment. Glacial isostatic adjustment is very difficult to monitor numerically, but it is. We have a lot of data on the rise of the oceans. So in a preliminary study, I did a look at the combination of the projected rise in ocean level, the sea level, which is very dramatic and is well established, and as a proxy for glacial isostatic adjustment. So we have data going back a long time being something like 80 years of sea level data. And we have projections of the sea level made by oceanographers who presumably know what they're talking about when it comes to the rise in sea level. If you combine those two, and neglect the fact of this possible correlation with the motion of the core, then I found that there will be certainly a negative leap second relatively soon, within the next 5 years probably, and that mainly because the rise in sea level, even the most conservative projections for the rise in sea level show a parabolic increase and that will greatly affect the rotation of the Earth. So with that in mind, I suspect that we may be headed for a negative leap second sooner than we thought.
Denise, hello. I do not understand your point because such ice melting produce a positive trend in the length of day, so it will.
Now,
it does not produce.
If we look at the correlation between sea level rise and the length of day, it's fairly dramatic if you look at the correlation, and if we attribute that to glacial isostatic adjustment, then it means that the glacial isostatic adjustment, I suspect, has been underestimated. But
maybe
we'll see.
Maybe it's you mean that the trend associated with the glacial isostatic adjustment combined with the present ice melting is not well determined?
It's very difficult to get numerical estimates of the.
Yes, I agree that with you. Yes.
So I just used the rise in sea level as a proxy for.
Okay. You use it in order to determine the total effect, including total. Yes, indeed. According maybe you see the slide readily now. I give the model, the trend on the length of day caused by the glacial isostatic adjustment, and you can see here the large uncertainty of the model. The uncertainty is almost the middle,
Right. I just used the sea level data, which is brought to us by a number of ocean studies, and as a proxy for glacial isostatic adjustment, because it is extremely difficult to measure glacial isostatic adjustment because you have to have stations all over the Earth, and it's not easy.
Yes, it's a model. But anyway, according to my understanding, the problem is the key point is the motion of the fluid core in predicting the negative leap second, because the effect, present negative effect, exceeds the effect of the glacial isostatic adjustment combined with the present ice melting. So if we cannot predict the behavior of the core, we are not able also to predict anyhow the leap second.
Thank you, Christian. Thank you for the question. Any other hand raising? Christian, we should take a decision on when applying the continuous UTC at the end of 2025, because it is the General Conference in 2026, but the General Conference in 2026 has to be prepared 1 year in advance. So we can have some doubt at the end of 2025, but we should have an idea of what we want to do. So if we go again to your plot on, yes, this one, in 2025, at the end of 2025, which is in 1 year and a half, do you think we will be able to see if we are on the blue or on the yellow?
I'm not sure.
And may we take this plot as the red is the best prediction, and the blue and the yellow are the two
I cannot say this is the best prediction. I cannot say a prediction is already a kind of bet, so I will not.
Yeah, so
I will not bet any money.
So what do you advise? What shall we do?
I only advise to increase the tolerance to stop, of course, the leap second system and to increase the tolerance. That's
Yes,
all.
because you said in less than 100 years, we will
Yes.
have more than 100 seconds.
Maybe they say, because if we cannot predict anything for sure.
Yeah, the possibility of a negative leap second is mostly related to the date in which we want to implement a continuous UTC.
Yes. Mm-hmm.
Because we said in or before 2035, the ITU recommended 2035. So in principle, we could wait 2035.
Maybe.
If not for the fact that people are scared by the negative leap second, which has never been applied and represent a risk to many of our member states. So if we want to go deeper and try to estimate the percentage of this risk of a negative leap second, which are your advice, and also Dennis and other, what can we do from now till the end of 2025 to try to put on the table everything we know and decide if we want to run the risk of a negative leap second or not?
I think we are at the crossroad of unpredictable phenomena. So we don't know how the fleet core will now behave. We don't know if the ice melting will increase. No, we don't know. I can tell you I cannot recommend anything. I only recommend to wait for it to look at. Except to increase the tolerance to stop the leap second system, I can only recommend to stop the leap second system and to increase the tolerance to 100 seconds or more.
Okay, so
but I refuse to evaluate any risk and to do any prediction, because any prediction are wrong, especially on the long term. Cannot predict anything.
Yeah,
I refuse to predict. For me, it's a pitfall. So we can, yes, consider different prediction, but to evaluate how to evaluate probability of phenomena we don't know, we cannot predict. I don't know.
Yeah, I would certainly agree with Christian. It's very risky to make any predictions on that, and every time you make a prediction, you'll see yourself in the headlines of the newspaper, and that's a very unsafe thing. So I would, in the case of prediction, the best thing you can do is assume it's what it is today.
Yes.
Noel?
Yes, I agree that it's very difficult to make a prediction, but at the same time, we have to take a decision in 2026 about the date of application. And it's important to have this prediction in 2026 to be sure that UTC will remain the international reference timescale. Because if there is a risk to have a negative leap second, and if we decide nothing in 2026, so if we accept to live with a strong risk to have a negative leap second, many systems, many operational systems will choose a reference timescale that is not UTC. And I think we will lose UTC as the unique reference timescale for all applications. So this is another risk, I agree. But we have been fighting with CCTF, with Patricia and all of you to have a continuous UTC since, let's say, months, years, and decades, because we want that UTC remains the international reference for time. And so this is another risk.
So according to this plot, there are some holes. I present sometimes all the scope, all the of different extreme case predictions. So the annual scenarios and the common leap second prediction. So you can see that the leap second prediction, ever negative or positive, will not occur before 2030. So we have still 4 years before us, or 6 years.
Yes, but I heard Denis telling us that
Yes,
there
it was
a
alarming.
risk to have
A risk to
in
29, but
the 5 years to have
the
this.
5 years.
Yeah.
But when you look at that curve actually of UT1 minus UTC, you can see that the trend in UT1 minus UTC has slowed down and now is almost stabilized. So somehow UT1 minus UTC oscillates around 0. You see there was a trend from 2020 because the length of day was negative. The length of the offset, sorry, not length of day, but the length of the offset was negative. So that causes an increase of the UT1 with respect to UTC. But now you can see that that increase has slowed down, is almost stabilized, and probably will reverse. It's my own feeling. That's but it's subjective feelings. That's now it will reverse. It will not increase. It will not increase according to the blue curve, but rather reversed according to the orange curve. It's my own recommendation, but fully subjective.
Thank you, Christian, for all the detail. May I ask if you plan to publish this study so we will have a reference to use?
Okay, I could try yet to dig deeper, to do some publication, exposing any kind of scenario.
Yes, and then maybe we will come again in the next 1 year and a half or 2 years. We will come again on this topic to see how things evolve and to see if we are on the blue, on the red, on the yellow, or on another
It will be interesting
curve.
to compare in 1 year those predictions with reality.
Yeah, okay. So thank you very much. Sorry, we have to go on because we have still half an hour and we still have a big topic. So thank you, Christian. And
thank you again for your attention, for your interest, especially for your interest.
Yeah, thank you. So the next speaker is Judah Levine, who will discuss a possible extension of tolerance between UT1 and UTC and a possible procedures to periodically readjust UTC. So Christian, you should stop sharing.
It's done.
Yes, and Judah?
Yes, thank you. Let me see if I can share my screen. It's
not in presentation mode.
Yeah, I know. Just I think I just lost it. Is that better?
Yes, thank you.
Okay. Well, okay. Okay. Let me just give you some information about discussions that I have had for many years with Patricia Tavella, a very, very lengthy discussion with Patricia Tavella, and also with many other people inside of the climate community. On the other hand, the discussion that I'm going to give you is not necessarily the opinion of anybody else. So it should not be taken to be anything other than my own personal opinion. Now, the outline of my talk, I'm going to give you a few slides of issues of what I call considering, which are reasons why a solution should be chosen. That is why what we should do, I present them not in any particular order, mostly in the order that I thought of them. So it's not like the first one is the most important. It's just the order I thought about it. Then I'm going to give you a solution that I propose, and the solution is really made up of two parts. There's a basic principle of the solution, which is an algorithmic adjustment. And then there are details which describe how the algorithmic adjustment might be implemented. But those two principles are really separate. The principle, the algorithmic adjustment, and the way of implementing it are really different pieces of the proposal. And one could imagine other algorithmic proposals, other algorithmic solutions that were implemented in a slightly different way. I'm going to give you a summary of what I think of as the advantages of my solution. And of course, it's my solution, so that's my advantages. And then I'm going to leave you with a question, in which I have tried to condense the entire subject onto one slide. And of course, that's a very difficult job. So I will leave you with that question. And in my view, that is the real question. So that question is really the thing that we have to decide. So first of all, let me begin with the considerings. I think the first considering is that I think there should be we should keep a link between UTC and UT1. I think that is something that I think we all agree upon implicitly. The resolutions of the BIPM and the ITU that they should increase the tolerance. To me, that means that if we increase the tolerance is not sent to infinity, so that there is still a link. On the other hand, when we make a change from the responsible metrology perspective, we should minimize the disruption that will result from any change. And that is the way we have always redefined things, is we have tried to minimize the disruption to everything else. We worry about the GNS broadcast formats, which can tolerate some level of UT1 minus UTC, but which would break, well, the different broadcast formats will break at different places, but all of them will have problems sooner or later, and we have to at least, whether we decide that that's important or not important, we should be considerate. There are ephemeris data and tables, and there's all this stuff. There's applications that receive UTC, but really depend on UT1. And the report of Working Party 7A contained a lot of information about that kind of subject. I'm not going to discuss this in any great detail, mostly because I just don't have enough time. But there's a lot of information about these kind of issues. There are legal and regulatory references that implicitly depend on the difference between UTC and UT1, Greenwich Mean Time, mean solar time, all this kind of stuff. And we have to be cognizant that if we make a change, we have to at least think about the impact that all of this change is going to happen on all of these effects. Consideration number two. My opinion is that an adjustment process should not use a time step of any sign, period. I think positive leap seconds and negative leap seconds cause trouble. We are currently discussing the difficulties of negative leap seconds, but in fact, positive leap seconds are still causing trouble after 50 years. And Patrizia Tavella and I had a publication in Metrologia which discussed this point. But even after 50 years, there are still problems with positive leap seconds, and so my consideration is that we should not do time steps. Period. It's simply a problem, no matter how you choose to do it, and it violates causality, it violates monotonic timescales, whatever, and on and on. Okay, that is, the adjusted timescale should be single valued, monotonic, and preserve causality, and I think that is, in my mind, whatever we choose to do, these considerations should be considered very strongly. My proposal is to use internationally frequency offset to perform the adjustment in a way, which I mean that we all agree, the timing laboratories, everybody agree that we're going to amortize leap second with a frequency smear, except unlike Google and Microsoft and all these other places, this is an internationally agreed upon frequency smear. We're all going to do exactly the same thing, so that it is something which is, you don't have to know where the data came from, because everybody's doing the same thing. Now, I think the frequency smear should be algorithmic and digitally defined so that it can be removed. That is, if you don't like that frequency smear for whatever reason and you want to recover TAI, there should be a simple, straightforward way of doing that. And that, again, is unlike all these other private smears that have all these complicated functional forms. I think they are all very clever in some way or other, but they are a fundamental mistake. We should have a frequency smear that can be removed with as easily as possible, so that someone who doesn't like the frequency smear for whatever reason can remove it. And I'll give you an example later of what I mean by that, but that's the basic principle. Consideration number 3, the adjustment process should be algorithmic and unchanging. One of the difficulties that Patricia Tavella and I have commented on, and that everybody else has commented on, is that the irregular and unpredictable adjustments are a serious problem. Independent of how you make the adjustment, the fact that the adjustment is not regular and not predictable and not algorithmic has made a serious problem. And in fact, that's one of the most serious issues with the current leap second system. In addition to all the other possibilities, the fact that they come and they go at irregular intervals is a very difficult. And now, on the other hand, the adjustment process should not be forever, because it needs to be such that it's frequently enough that software becomes developed and tested, so that we don't have this possibility that in some future era a leap second or leap event occurs and it has not been done for 100 years and nobody's ever done it before, and that is also a mistake. So it should not be too rare, but it should not be too frequent either. And my proposal is every 10 years, but that's a detail. That's an example of where you should separate the idea from the implementation. But I think it's important that we have an algorithmic process that is not too frequent, but on the other hand, not too rare. Number 4, the adjustment process should be implemented outside of normal business hours, simply because 0 UTC is a bad choice. And my proposal is 12 UTC on 1 January. Again, that is a detailed of the implementation. The problem with 0 UTC, of course, is that it does not recognize the difficulties of timescales in Australia, in Asia, in Canada, in California, and so on. But again, that's a detail. And now, the general principle is that we should split the evaluation or the evolution of UT1 minus UTC into 2 pieces. The first is the long-term evolution of UT1 minus UTC, and we should try to use as best as we can the data from the previous century and an accumulated offset. And now Dennis McCarthy has an estimate. There are a whole bunch of estimates, and I have published a rather very lengthy discussion of all these various estimates. But all of the various estimates suggest that the UT1 minus the length of the day has been increasing for centuries, and there's a difference among various authors about how much it's been increasing, whether it's this number of milliseconds per century or that number of milliseconds per century. But every number that I know about is positive. Now, but on the other hand, as Christian's mentioned and as very other people mentioned, is there are significant deviations from that linear trend. And that's, of course, what makes it so difficult, is that the deviations can persist for a number of years. And so in addition to the trend, we should define a maximum tolerance which is large enough to deal with these irregular predictions, so that the tolerance is driven by, historically, if we look back and ask what was the maximum tolerance that was needed such that when we use an algorithmic linear prediction, we have enough tolerance to deal with. The tolerance is large enough to deal with the irregularities that are unlikely to happen. In the language of Christian, that is, we have a tolerance which is large enough to accommodate his various scenarios. And that way, we don't have to worry about exactly whether this is going to be a positive event or a negative event, because the tolerance will take care of it. And that the algorithmic event takes care of the very long-term increase, which, as I said, every estimate that I've seen is that the length of the day has been increasing. And the only difference is what number Dennis would like to assign, or somebody else would like to assign, or this data or that data or the other data. And the numbers vary a lot, but they're always positive. Consideration number 5, okay? We should not leave a problem for the future. I think that is a bad choice in general for us to do something which we know is going to be a problem in the future. One of the difficulties is that when we do that, the solution is often discussed in crisis mode. And the negative leap second discussion we've been having is an example of that. Okay, that is, we postponed the discussion which those people in 1972 knew would have happened or could have happened, and they decided not to deal with it. And now here we are dealing with it in semi-crisis mode. Those of you who are old enough may remember the Y2K problem, which was the same kind of problem. The fact that the year was going to change from 1999 to 2000 had been known for 100 years. But of course, it wasn't dealt with until the last microsecond or the last millisecond or the last days. And the result of that is that there are, we always do this in panic mode, and that is the wrong way to make a decision. We should not do this kind of stuff again. We've already done it twice or 3 times or 4 times, and we should learn a lesson not to leave a problem for the future. Okay. On the other hand, as Patricia said, as many other people have said, we may have increased understanding, and of course we're going to have increased understanding. And no matter what we decide today, no matter what we decide tomorrow, we can always modify it based on future understanding. If whatever we decide now, when we learn more, we'll do something smarter. Consideration number 6. Okay, the solution should be as simple as possible. Okay, the maximum tolerance should be as large as possible. And of course, this is I'm sort of taking the other side now. That is that let's not deal with all this algorithmic stuff and all these stuff and so on and so on. Let's just make the tolerance as large as we can possibly make it, so that the adjustments almost never happen. Okay, any periodic adjustment is too complicated. Judas solution is all that clever, and it tries to deal with this and it tries to deal with that and it tries to do the other thing. But the problem is that it's too complicated. Okay, periodic adjustments will not be accepted by service providers. Now, that's not a fact, of course, that's a concern. And it's a legitimate concern. It's hard for me to tell what would happen. I think Google and whatever make noises, but those are noises. That's a difference between noises and a decision. But it's a concern that trying to be too clever may not be a good solution. Okay, and in fact, the basic of this argument is that if you need UT1 minus UTC, you'll use the IRS bulletin A. And most users don't care about UT1, and they don't have to bother with any of this stuff. It's just too complicated. It just don't bother me. Okay, and in fact, a corollary to this thing is that a difference of UT1 minus UTC as large as an hour is not a serious issue. And I'm not sure I agree with that, but it's my job to present the possibility or the opinion. And so this is an opinion which I think is in the opposite sign to my previous considerations. And it's of the let's increase the tolerance to do nothing kind of solution. And I think it's the wrong solution, but I think it's important that I present the possibility as something that we should think about. Okay, and in fact, the people who think this is important may be of the effective opinion that this consideration is more important than all the others, and that this consideration outweighs all of the other choices, and that this consideration decides the question. We set the tolerance to an hour and forget about it and go home. Now, let me just so those are the things that I think of as the considerations. Let me turn to a solution, and of course the solution, as I said, has 2 pieces. It has the fundamental idea of an algorithmic solution and the implementation details of how you might implement the algorithmic solution. Okay, so we should calculate the evolution of UT1 minus UTC over the previous century. That would, assuming the transition was 2035, then we would look from 1935 to 2035, and we would estimate the evolution of UT1 minus UTC over that century. And there are already a number of estimates. There's Stevenson and Morrison, there's McCarthy and Babcock, there's all these estimates, and we would do the best we can to get the estimate. And we use this rate to predict the long-term evolution of UT1 minus UTC for the next century. Okay, we adjust UTC by 10% of this prediction every 10 years. Okay, and so we'd expect that over the next century, UT1 minus UTC would increase by X, whatever the best estimate would be, maybe 100 seconds, maybe 200 seconds, whatever. And so we'd adjust UTC by 10% every 10 years. So if we thought that UT1 minus UTC would increase by 100 seconds in the next century, we'd adjust UTC by 10% of that, 10 seconds every 10 years. And I don't mean those numbers to be definitive. I mean those numbers to give you an idea of how it would actually work. Okay. Now in 2100, we'd look and see what would happen, and we'd get a new rate. That is, we've been watching UT1 minus UTC for the century, and we recalculate the evolution of UT1 based on the contemporary data. And of course, we might have made a mistake. That is, the rate we've been using might have been too big or too small, and so we might have an accumulated offset. And we now have a new rate applied for the century starting at 2100. But the principle would be the same. That is, the algorithmic adjustment would stay exactly the same. The only difference would be the magnitude of what happened every 10 years. So the adjustment magnitude would change every century, but the adjustment process would be unchanged. Now the assumptions, okay? The long-term increase in the length of the day will continue for at least a century. And when I look back at the historical data, back to 1650 or something like that, every estimate that I have, every estimate that I've seen published is that number is going to be positive. Okay. Now you can discuss the magnitude. Maybe it's 13 seconds per century squared. Maybe it's 23 seconds per century squared. I'm not so much interested in the magnitude as I am in the principle. On the other hand, remember that the difference in predictions is not significant over a century. If I say that it's going to change by 13 seconds in the next century or by 23 seconds in the next century, well, it's not such a big deal. Given that the tolerance is going to be 100 seconds, a difference between 13 and 23 is not so significant. Okay. On the other hand, we have all seen there are deviations from the linear historical record, and the deviations can last for decades. Now, whether they're periodic or not periodic is another discussion. I'm not so sure that you can be so clear that they really are periodic, but the fact of the matter is that they're deviations. If you look back in the 19th century, the largest deviation would have made a change of 22 seconds relative to the linear increase. In other words, if you had adopted a linear increase, then you would have been zinged by something like 22 seconds when you had one of these deviations. Okay. On the other hand, the maximum deviation from a linear trend is less than 60 seconds in the historical record. If I go back to 1657, I can't find a time when I would have made a mistake of more than a minute against the long-term trend. Okay, so if I chose a maximum tolerance of 100 seconds, it would have absorbed every deviation for linear increase in the historical record. Okay, so I don't have to worry about positive events or negative events. It's all absorbed in the tolerance, and I chug along with my long-term linear rate. And the tolerance absorbs all my mistakes and all my irregularities and everything else. That's the point of the tolerance, is it gives me wiggle room so that I can deal with these difficulties of predicting the models. So it's an adjustment process. Now again, this is an idea where you adjust the clock frequency by exactly a factor of 2. And so I give you an example. You can sort of see what happens. And I've done it in milliseconds, but it could be done in anything. You essentially skip every advance for positive, you double every advance for negative, and if you don't like it, you back it out because it's a digital. Okay. So let me summarize. Okay, the algorithmic adjustment it addresses many weaknesses in the current process. The adjustments are predictable. The time scale is monotonic. The time scale is single valued. The adjusted time scale would differ from UT1 by 100 seconds or less. And that's a significant effect. Okay. The adjustment process is digital and universal. It can be algorithmically removed to recover TAI exactly. If you don't like what I'm doing, you can undo it. Okay. The maximum tolerance absorbs the irregular variation in UT1 minus UTC because the departure from long-term rate may last for decades. As Christian pointed out, he says it's 136 years, 60 years and a half. Okay, but there very definitely are 60-year deviations. Okay. The idea was that the current increase in rotation rate is absorbed in the tolerance. We don't have to change anything. And now let me, having given you what I consider the whole things, let me leave you with the questions, which is really what I think of as a real issue. Okay, are the considering points essential in defining the solution? That is, do you take my considering points and are they essential? You have to find a solution that agrees with them, or perhaps they're not essential. Perhaps they're only desirable. Okay, that is, it would be nice to keep those to find those considerations, but they're not. They're only desirable. And in fact, changing for an hour and doing nothing is consistent because that's what it is. Or you could say, yeah, that's not important at all. Okay, you've just made it up. That's not important in defining a solution, and just erase that slide altogether. Okay, finally, should the decision not to change before 2035 be reconsidered? And I think the answer to that is yes. Whatever we decide to do, the answer should be waiting to 2035 is really dangerous. I think the question of a negative leap second, we have to multiply the probability, and you can take whatever number you like for that probability, but you have to multiply that probability by the effect. And the probability could be anything, but the effect is large. And that's a very significant problem. So I think we ought to change, and whatever we do, we should do it before 2035. Okay, that's all I have to say. Thank you.
Thank you, Judah. You gave us again a lot of material for discussion and for thinking. Any question, comments? Christian.
I skipped part of the presentation. Maybe I did not, therefore I did not understand everything, fortunately. So you propose to adjust to, how to say, to adjust UTC, to adjust CTT in order to monitor somehow the regular part of UT1 corresponding to the quadratic evolution of UT1. Time quadratic. Exactly. So yes, it's very good idea. I understood. So in doing this, you will so UTC, this adjustment will be regular because parabolic term can be predicted is a regular term. So it will be regular adjustment at fixed date, at fixed. So how I did not understand the way you will operate adjustment.
I will adjust UTC by some number of seconds every 10 years.
Every 10 years, yes, it will be.
And the adjustment will be done with a frequency sphere on January 1st every 10 years.
Since yes, it's a very interesting option because then UTC will be still a proxy for the Earth rotation time, but with an increased tolerance. Yes.
That's exactly the point. You understand exactly correctly.
This will be a way to give up the Earth rotation time. Yes, to disconnect totally Earth rotation time and UTC. It's interesting.
Dennis.
I just had a question, Judah. When you're adjusting every 10 seconds, is that you mentioned earlier the business of you would sort of have a long-term 100-year frequency in mind?
Yes, that's right. For example, I would take, just as an example, I would take your number of 13 seconds per century squared. I would project forward to 2100, and then I would figure out what's going to happen, and then I take 10% of that every 10 years.
Yeah. So would you, this decision of 100 years is made every 10 years?
No, no, the decision for 100 years is made every 100 years.
Made every 100 years. That, it seems to me, this is sort of a compromise between the good old days when we adjusted the atomic frequency by a certain number of parts in 10 to the 10th. And
right.
You know, it's a compromise between the two systems where we're sort of...
That's exactly correct. The point of this whole thing is that I am doing my best to spread the unhappiness around, or to spread the happiness. Yes, that's exactly correct. I'm trying to find something which accomplishes everything, and of course it's an impossible situation to actually make everybody happy. But yeah, I mean, I chose these numbers sort of semi-arbitrarily, but I thought, you know, not changing for a century is probably a reasonable thing. And I mean, I took your number, I took the Morrison number, and you know, they're different, and what can I say? But they're all positive. That's the point. They're all positive.
Any other comment? Yeah, unfortunately, we don't have so much time, but I am sure that if we start thinking to what we have heard and which are the possible solutions, I think we will have a reaction. And so even if today we may be shy in saying something, I would like to invite you to use the email of Judah and mine to send comments and your idea. The presentation will be stored on the usual web page. I will give you the link. And I think it would be important to try to stay tuned and try to discuss that.
I agree, but I think it is also important that the comments not be individual. That is an email message sent to me, and my reply to that email should somehow be shared among the community. I don't know the mechanics of how to do that, but I think it's important that all of us are aware of the conversation. You know, however the conversation turns out, we should all be on the same page, so to speak.
Yeah. We have a forum for that. It was not very much used. We had also a Git open for that. It was not very much used. So I think that maybe the best is that some of us will meet in the next congresses or in other meetings. And I think we really need in 2024 to stay tuned and try to converge. And Judah is right. It's not only individual thoughts, it would be better to try to converge. And I would like only to add one comment to this discussion. And the fact is that, to my experience, most of the industries say we use GPS time. We find in GPS time what we need because it is a continuous time scale. And so it is a convenient standard. And as BIPM representative, I am not very happy to hear that some community wants to use GPS time as international standard. This is why I think that any adjustment in UTC will never be accepted by this type of users, and they will say, do whatever you want, we use GPS time. So I would...
So sorry, but Patricia, I agree with you, but I think you do not identify one of the reasons why that happens. And that is, especially in the United States, there is no good alternative. It's not like you can find something else that is, GPS time is so easily available and so generally available that and that is really the reason why, at least in the United States, I mean, I can't speak for other countries, but in the United States, there really is no good alternative from the technical perspective. Never mind leap seconds or anything. There's just no other good way of getting time at that same level of accuracy. Thank you.
Yeah. So as we have just a few minutes, I would like to go to the next topic. As we were saying, we will have an occasion at the European Frequency and Time Forum. I know we will not all be there, but together with Judah, we have submitted an abstract which has been accepted, and we want to just say what we are doing, which are the topic under discussion, what has been achieved, what it is still to be discussed. And so we have proposed a paper that you see is on behalf of the task group on towards continuous UTC, which is this task group. So we will prepare a presentation and send it to you, and it will be really important to have your comments on the presentation and on the topic. Then there are other communities to which we would like to bring this discussion. So Judah, for example, attended the WSTS a few months ago. Judah, can you just say a few words on the
Yes,
message?
sure. I had very, I presented a paper on my, basically on a somewhat different version of my proposal to WSTS, and the general feeling was, boy, that's very interesting. Let's think about it. But if you listen to the talks at WSTS, almost all of them start out with a GPS antenna, which just confirms what Patrizia said a few minutes ago. These are mostly telecom people, and they just use GPS, and they do it not for any philosophical reasons or not for any great thing, just that it's there and it's available. Speaking privately or as not a member of the United States government, I think we have made a terrible mistake. But I can't speak for the United States government, but I think we made a terrible mistake by not providing an alternative to GPS. And what can I say? I'm not a member of the government. Well, I think we have done something very, very bad, and we are now seeing the fruit of it.
Yeah, I understand. I also agree that now we have an issue, and maybe we could have done better. But the fact is that now we have an issue. And then Mike Coleman is also working with the Civil Committee of GPS, and Mike and others are working with the GNSS International Committee. Mike, I don't know if you have any comments.
Only that I did speak with Patricia Larkowski, who heads the timing subcommittee at CGSIC. Did she contact you, Judah? I think she did, but you were.
Yes, she did. Yes.
So she asked me if I can put together some comments on what we're doing here, which I can certainly do, but I'd like to make sure that you and Patrizia and whoever else see those, and I make sure that I get right what we're talking about. But that is an opportunity for me to talk to the people in control of the GNSS systems, because they do tend to come to those meetings. And for what it's worth, anything we start to coalesce on would be valuable for them to hear about it and possibly to give feedback, because it is very challenging, I've found, to get anything official, even from, and I work in the GPS community, I'm fairly deep into it, but getting anything official from the higher ups is quite a challenge, I have found.
Yeah, something else we can do is to have a sort of official presentation that we can share among us and that can be used on behalf of this task group to explain to the other community what we are doing. So we have to distinguish between personal view and the official task group work. But I think, Michael, that you can have a presentation if it is useful to you.
Okay.
And then we had the idea to organize a workshop, and we don't know if it is better to invite people to join our community or if it is better we go towards the other community. We are trying to do both. So this is why we try to be present in the different congresses. And also I would like to ask to the CCTF chairs if we can speak of this topic at the annual meeting of the regional organization. I have already been invited by some of you, but not all. So for example, I think Comet, Afrimet, GulfMet, we don't have a contact. So I don't know if Chris, Matti, are you still there?
Yes, I'm still online.
Yeah. Do you plan to organize an Afrimet meeting on TCTF?
Yeah, so we will start looking at dates actually this week. So when I have a date, I will inform you. And it will be an online meeting, which will make it easy to attend as well.
Oh, yeah, that is great. Thank you. And Walid Al-Kalbani, I don't know if you plan also to have a GulfMet meeting.
Yes, Patrick. Actually, we have now separate the TF from the EM. So I think we nominate Khalid Dawood as the new chair, but not officially. Maybe in a few days he will be the officially TC chair of the TF. But I will write that one to him, and for the next meeting, he will invite you.
Okay, that is very good. Thank you. And then from Comet, I'm sorry, I don't remember in this moment the name of the TCTF chair, and I am not sure he is here with us.
Dear Patricia, TCTF chair is not here with us right now.
Okay.
I don't have information on the next Comet meeting regarding this issue, but I will get it and give it to you.
Okay, yes. So please stay in touch and let me know.
Of course, thank you.
I have been invited by Euromet, and I don't know about SIM. Do we have Diego Luna? Maybe is online. No, maybe not. Marina, do you have any information about that?
I don't have any information about the next SIM TCTF meeting.
Yeah, in case, can you please propose to have the possibility to explain what we are doing on the continuous UTC?
I will reach out to Diego and suggest he has a meeting and invites you. Thanks, Patrizia.
Yeah, thank you. And for AP and P, is the chair online now?
Hello, I think Dr. Hosaka is here.
Yeah.
Can you hear me?
Yes.
Hi, I'm Kaz. Yes, in the case of APMP TCTF, we will hold the meeting in November in India. So at the moment, we haven't fixed the agenda of the TCTF, but we will think about it in soon.
Yes, thank you. So we are in contact.
Right.
Yeah,
Yes.
we are in contact, and we will be pleased to have the opportunity to talk with your regional organization.
Yes.
Thank you. So thank you to all of you for the activity you are preparing, and I think we should stop maybe with a meeting in 1 or 2 years again with the expert on earth rotation. So Christian, maybe we will invite you again because we think it is important we update your plot with the observation, with the prediction. And so, yeah, just let me remind that the CCTF will meet in November this year in the first session, and the second session, which is the final one, will be in September 2025. And so September 2025 is where we need to take a decision. In November, we can say some preliminary view, and then in 2025, we should decide. And so it is important that in 2024, we discuss, we participate to the different meetings. Also, I know that URSI had a meeting and this topic was discussed. So it is important we disseminate as much as possible this view, and then we converge in a next meeting, which will be probably in September, and then we will prepare a draft resolution. I think, yeah, then you know where to find papers. So I think we can close the meeting, and I'm sorry to be late, especially for the people in Asia, because it is now late in the night. May I just ask to the speaker if they agree that we publish on our webpage the video of this meeting?
Maybe the best will be the presentation slides themselves.
Yeah, the slide will be for sure available. If you agree, we can also put the video.
I will send you my slides.
Okay. And
Patricia, no problem from my side.
Okay.
Yeah, I agree. No problem. I will send you the slides, the final version of the slides.
Okay. Thank you. So any other comments? So thank you very much for being here today. Thanks you for listening. We will put all the material online. And let's hope to meet as many of you as possible at the next European Forum and in other occasions. Please remember what Joseph said, that also the ITU need expert in time and frequency meteorology. And so see you soon. And also we will stimulate offline discussion with some suitable techniques. Thank you very much.
Thank you, Patricia.
Thank you.
Thank you and bye-bye.
Bye-bye.
Bye.
Bye. Nice to see you. Nice to see the face coming up.
Thank you. Bye-bye.
Bye. Bye, Liz.
You. Bye-bye.
Hi, nice to see you.
Nice.